Hey everyone, thanks for joining us on Tuesday afternoon of reInvent for a talk on legacy migrations. I'm here today with Mike Gologorski, Senior Director of Business Technology at Cisco. My name is Mike Lapadakis. I'm a Solutions Architect for AWS. When Mike and I were planning out this session, we really wanted you all to come away feeling like you experienced a legacy migration, that you'd experienced both a failure of a legacy migration and the success of a legacy migration. And with that experience, you can take that and go move your own application. What's not included in this agenda is a Q&A at the end. So we're going to leave 10 minutes. We have 2 mics, and you all can ask questions to Mike and I. We'll also be around afterwards in the hallway if anything can't be covered. So I'm going to kick it off by talking about AWS and migrations in general. If you're using AWS today, you know that we have a plethora of services that are out there to support your migration efforts. And we're releasing new services in this capacity based on customer feedback all the time. Just 2 days ago, we released AWS Data Sync that further extends our ability to move information into AWS, move data into AWS in a seamless manner. So at the center of this is the AWS Migration Hub. We have services that range from application discovery all the way to moving actual bits, and finally keeping databases in sync so that we are able to cut over in a seamless manner. Now, it's not enough to have a plethora of services that support your migration effort. It's also good to know that you're walking in the footsteps of giants. And organizations of all different shapes and sizes have successfully migrated to AWS. So we have Cisco up here with us today, but if you go to our migrations landing page, you'll find case studies from McDonald's, Ticketmaster, GE, and others who have also migrated to AWS in varying capacities. Now, for folks that have dabbled in migration or cloud adoption in general, you'll know that migrating and the technology itself oftentimes isn't the most challenging thing. Cultural changes is equally or oftentimes more challenging for organizations. AWS Professional Services has put together the Cloud Adoption Framework. This is a series of white papers that actually call out some of those challenges that you may experience and give your organization a method and a rubric to follow in order to be successful, both educating, hiring, and training folks. Now, for Cisco in particular, what you'll hear about here in a moment, RME. RME was a project. It was the very left-hand side of this graphic, and it really propelled Cisco forward. It propelled them through the migration phase, and now today when we talk to Cisco, they're in the reinvention phase. They're building fresh applications that are actually rewritten and repurposed applications from things that existed on premises in a cloud-native manner. And when it comes to migrations, there's a number of different ways that an application can be migrated. And it's important to classify the migration effort before you kick it off. You may have a simple rehost, which is basically moving the application in its existing form into AWS. You could have something like a refactor, where you're actually using cloud-native technologies within your re-architecture of the application in order to take advantage of all of the benefits of the cloud. For RME, which the application you'll hear about here in a moment, it started as a simple rehost. And we changed that to replatform. And then after migration, and we'll go in more detail here in a moment, we actually refactored it in order to take advantage of, again, those cloud-native technologies that allow us to be more resilient for our customers. And with that, I'm going to kick it over to Mike G., who's going to tell you all about Cisco.
Thank you, Mike. So a little bit about Cisco. We are global leading companies focusing on selling products and services to our customers. You probably guys see a lot of our trucks out in Vegas with a big Cisco logo, but what we're really focusing on as Cisco to be a customer's and most trusted business partner. There's a couple of things that we really passionate about is really focusing on enriching a customer experience. It's focusing on operational excellence. Obviously, again, you guys see trucks out on the road. You see our trucks in front of the hotels. Really activate the power of our people and really doing the business the Cisco way. At glance, so I know you guys seen a lot of presence from Cisco, but we are actually a $400 billion company with a presence in Americas, and we're growing in Europe, Ireland, UK, France, among other countries. We have different brands. Think of it broadline business with about 1 million SKUs. Plus, we have a specialty companies that's focusing on produce or specialty seafood and so on. So Mike talked about RME. What the acronym stands for is Rehosted Mainframe Environment. So what we've done, again, this is a journey that we took on several years back. The first thing that what we did as a company is we focused on take out the ZOS because we had a large ERP system, environment costs just going through the roof. So what we decided to do is we actually re-platform from ZOS to Windows using Micro Focus platform. That positioned us in a nice way. We got everything kind of worked out, and our core ERP was running extremely well. However, just with, if you look a couple of years back, I would say 4 or 5 years back, where we were when we hosted in-house. And usually the way that that works is probably everybody familiar with, you buy a hardware, you run the hardware for 5 years, but in our case, if you look at the previous slide, obviously we're growing through acquisition. And that created a lot of challenges for us because our growth could not keep up with the system. We use our core ERP for many different reasons. We have corporate billing, we have purchasing, we have finance. So we have millions of dollars running through the system every day. We generate, I would say, about several terabytes of changes every week. So extremely large system, rapidly growing business. We want to integrate a little bit better, and really that became a catalyst for us to be on an environment that's more scalable, brings a lot more elasticity, and a couple of other reasons that we talked through the presentation a little bit more. The first thing when we tried to migrate to the cloud, we failed. And you don't hear a lot of companies talking publicly, hey, we tried this and it failed. Failure is a good thing. And what it did for us is flush out many things that we were just not familiar with, especially when it comes to moving large system. Mike is going to go a little bit more in details, but some of the things that kind of got us is truly understand the delta and the data size of your data that you're trying to move to the cloud. As we're running a large ERP system, performance, obviously, it's a critical thing. So we needed to make sure that as we move something to the cloud, the performance is actually better, not up to par, because again, we wanted to make sure that we scaling up not just for what we currently have today, but we wanted to make sure that we have an ability to grow with the business. And required resources are unknown, and that's both from, we try to understand both from the environment side and the skill set side, because again, we try to migrate the system that's old COBOL-based environment. And usually when it works, but nobody wants to try like unplugging and see what happens. So it's one of those things that was a lot of fun to kind of shake it and see what happens. Let me talk a little bit more about the architecture, what we have today. And we put a simplified version of this. Obviously, there's a little bit more behind it, and after the talk, if somebody's interested, we can talk about it. But basically, we took our existing environments along with the storage and the data. We moved it to AWS. We created the primary, secondary to make sure that we have the right failover. And we wanted to make sure that our data resides in multiple AZ, because that brings us ability to do failovers a lot quicker. We also put a lot of data that does not reside in database on S3 buckets, because that provides a lot of storage flexibility, and I'll talk a little bit more on what we're done with this. And all those boxes actually surrounded by load balancers, so it gives us a flexibility to scale up, scale down, absorb different loads on the system, and then scale it back down. Here's the interesting chart that I want to kind of socialize with you guys. So one of the things that cloud brings is actually a lot of interesting things that you can do. And this is actually a cost that shows we went live with our system, and our cost is actually increased a little bit. And that was on purpose, because what cloud gives you is a really good flexibility to say, you know what, for the next few months, until I know what I'm dealing with, I can actually scale up and extend my environments just so I don't hit any roadblocks. But what we've done aggressively is, after we validated the system works, we get the right performance, we actually start really aggressive optimization task, and some of my team members in here who helped us with this, we really focus on not only to bring the cost to the same point of where it would be equivalent on what it would take to host on site, but our goal, once we verify, yeah, when now the same cost, we drop it by close to 60% through various different techniques. This is the data lifecycle management that we implemented. So what we've done, just with any systems that's at a corporate, your own data center, kind of like if it works, don't touch it, but it actually created a lot of problems for us. And it's not only about the technology, it's really start looking back and talking to finance, talking to legal, and start talking about things that, okay, what about data retention? What are our policies? Can we comply with all the policies? And this is some of the things that we were able to do, is not only to take the data that's only needed in production, remove it from our core production system, but actually apply the right data policies and retention policies that can help us with this. So reducing your data load obviously equals great performance, but on the flip side, it also focusing on all the key things that you need from the legal perspective. Before I go to lessons learned, so we tried to do this thing in April 2016. We failed, and it was not easy. It was not easy going back to a CTO and saying, look, the team tried and kind of didn't work out. But we went back and we kind of said, you know what? We were this close. What didn't work out is the timing. We started on Friday. We needed to be back online for the business by Sunday around 1 p.m. And it was like we were this close, but it was just a lot of unknown. But we had a plan to back out. So we put the system back online. We were able to revert it back. We took a lot of notes. We went back in June 2016, so 2-3 months later. We went back kind of the next day, took a couple of really good notes, regrouped with the rest of the leadership in Cisco and said, look, we can do this. We were this close. We found out exactly the lessons learned that we're going to review with you guys. And we want to do this again. In June 2017, we were able, 2-3 months later, to redo this project again successfully, get it done. It was hard. I'm not going to sit here as like, hey guys, if you really want to move to the cloud, just use all the services and magically everything would work. Doesn't work that way. It was a lot of hard work that we put in. But we got it done. Here's the thing that I think I'm extremely proud of for Cisco, for my team, everybody the whole team who worked on this. I know you guys probably saw in the news, in August 2017, Houston had a horrible hurricane. Everything that we were responsible for in Houston did not impact the business. The system was already on AWS. A lot of critical infrastructure would also move to AWS. Luckily enough, our building was not hit, but the water was literally 2 feet away from the entrance. And that's not kind of the risk that we wanted to take. So with that, I'm going to turn over back to Mike. We're going to work you through, here's kind of the key things that applies to any projects with large data set, with large migration effort, and hopefully it's going to be a lot of useful information that we're going to share.
Perfect. Thanks, Mike. So having failed and then tried again and succeeded, we were in a unique position to actually capture those lessons learned and test our theories out. Make sure that the assumptions that we made on the reason for the failure was indeed correct. And the 8 that you see here, that wasn't all of the lessons learned, but for the sake of you all and the time allotted, we felt it was best to boil them down into the most relevant. So we hope that you'll come away feeling like these are going to be very beneficial for your future migration efforts. The first that we'll talk about is knowing thy data and thy delta. And what we ultimately mean by that is it's important to understand the size of the data, but also its composition, where it's stored, how it's stored, the size of each file. And the reason that's important is because other systems depend on the I/O that those files ultimately place during the migration effort. It's something we didn't account for in RME during the first go-around, and we'll talk a little bit more about exactly what that meant. In order to actually know your data, you need a tool to measure it. And as folks in system administration, you should know that there's a number of tools at your disposal. You can use things like SQL to run a query to dump the total number of tables that you have and the size of each table. You may use your storage array and its management tools in order to understand the data at a specific time. If you are taking backups, using the deltas between the different backups on a regular schedule will give you those deltas over a period of time. It's important to measure twice and only transfer once. And this is another mistake that we made during RME. We assumed that the first measurement that we received on the data delta over a period of time would actually suffice. Well, it turned out that a number of different financial factors, end of quarter, the number of reports that are generated on the system during that time, it actually changed the delta. So again, incremental snapshots will assist over time with actually capturing that data delta. And 30 days may not be enough for your organization. Go 90 maybe. Regular reporting from things like your storage array. And finally, keeping the business in mind, month end, quarter end, year end. Maybe you have an e-commerce business, and so things like Black Friday will play into the migration. I mean, these sound obvious, but oftentimes in our efforts to migrate, we lose track of other things.
Yeah, and just to add to what Mike was saying, I think it's extremely, extremely important of understanding that delta, because I think what kind of hit us a little bit more is we measured everything, we thought we did everything, but then we got that financial quarter got introduced, all the batch job ran, and over what we expected something to take X number of hours exploded. That, remember what I was saying, that the last couple of hours we just couldn't hit that target. That was it. And knowing all the data facts and knowing the delta, that's probably one of the key things that make sure that you guys are planning for.
Thanks, Mike. So speaking of planning, planning to fail is as important as planning to succeed. And what I mean by that is incorporating your rollback plan in your initial migration window, capturing exactly how long it'll take, at what point you'll need to say go, no go on the rollback. I remember vividly, it was 11 p.m. on Saturday. We had all got on a conference call during the failure and said, hey, can we make this work without impacting business on Monday morning? And it was determined that we couldn't. And that's when we took steps to roll back. So incorporating that failure time is crucial.
Yeah, and I think this brings to another really critical lesson that we learned early on. I think the reason that we failed, and we failed extremely graceful, is we actually knew that at some point in time, if something goes back, we had a playbook ready with all the steps on how to put the old system back. So as far as, we all exchange emails and we all had conference calls and conversations, but as far as our business concerned, when they walked in on Monday morning, nothing changed for them. The system was operational, everything worked, and there was no impact to the business. So don't play, obviously go for the success, but make sure that the failure is properly documented, and it's not just somebody knows potentially how to put things back. Make sure that you have a playbook, and make sure that you have a step-by-step instructions that you practice, ideally not the day you go in live.
Yep. So the next section, we're going to talk a little bit about storage, and specifically how we can optimize our storage for its destination. Every destination on AWS has an optimal block size or storage size, especially when we're talking EBS. EC2 instances in particular actually have I/O constraints that we need to consider. Oftentimes, putting more provisioned IOPS on a specific volume will not have the intended results if we're not considering our instance size and its I/O constraints. And finally, for large files that are ultimately ending in S3 or landing in S3, consider our multi-part upload and the different properties of it, the size of the file. So diving into the Ebs Io Size Considerations, talking a little bit about RME. RME had a file server, and the file server had millions of extremely tiny files. We're talking 1, 2 KB, adding up to just over 800 gigabytes. Now, at the time, we didn't really consider this a candidate for pre-seeding, and the reason why is because it wasn't really a large server, all things considered. When we're talking 20, 30 terabytes of overall data, a few gigs isn't really that significant. What we didn't consider was those many very small files would ultimately overwhelm our destination. And the reason is, when we're talking about EBS, we have to consider the optimal block size, and that's 256 kilobytes. And not only that, but we'll do our best, AWS and EC2, it'll do its best to actually write those blocks continuously if we have multiples coming through that are smaller than the optimal block size. But we will not write smaller than 32 kilobits. So what that ultimately means is 8 total blocks, 8 total files will be combined in order for a single write operation, which may only be 10, 15 kilobytes, not adding up to the 256 kilobytes required in order to get the optimal I/O for that particular instance type and EBS volume. So if you've ever stress tested or pushed into EC2 instance to its max, you'll recognize these two CloudWatch graphs here. The first is average write latency. The second is our average queue length. And these are two red flags when you're optimizing a system, especially as it pertains to storage. We want to make sure that our write latency and read latency are not high and that we're not building up a queue. Because as we're building up an I/O queue, those operations are being stored in memory and can eventually overwhelm the system. And we'll talk a little bit more about that in a moment. Now, talking about S3, we have different things to consider. The S3 CLI will automatically handle multi-part upload. So if you have a large file and you use the CLI's copy command, it'll break it apart into multiple parts and upload them concurrently. If your file is extremely large, though, you may want to consider customizing the block sizes and the number of parallel threads. You might also want to consider placing retry logic in there. So in the event of a network incident, you're able to retry automatically. For that, you can use the Boda SDK, something like Python, or actually the API and the CLI S3 API. It's a different command. Add to that the newly released AWS Data Sync, and there's a number of different options that you can use to actually handle writing to S3. Now, the other side of the coin is if you have a number of small files, in order to optimize your connection to ensure that latency doesn't impact the copy commands, you may use something like transfer acceleration, which allows you to use all of our points of presence, our edge locations, all over the globe in order to reduce that latency and copy files much quicker. Now, when it comes to legacy applications, there's a good chance that systems alone will not get you there. You have some appliance, some physical appliance in your data center that's actually part of the architecture of the application. And for those situations, looking to the AWS Marketplace is a great solution. So for example, with RME, it required that the data on a particular EC2 instance or a particular server was made available in a separate server instantaneously. This was for the availability. It was a DR requirement because it is a financial system. And in order to do that on premises, they used a storage array network with replication capabilities. Now, if you've built a server with Windows on EC2, you know that there's no native capability for replicating across availability zones and separate stacks. So Cisco looked to the marketplace. They found a storage array network that was a virtual appliance that was similar to that they used on premises, and they were able to incorporate that in the architecture in order to ensure that they met their compliance requirements and also met the performance requirements that we were looking for in the actual application architecture. So again, don't constrain yourself to the EC2 or AWS native services. Look to the marketplace to match or improve upon the architecture for your legacy application on premises. Now, we all know to test when it comes to a production deployment. We know that if we are updating our software, if we're rolling out a new tool, we want to test it in our dev or test environment in the same capacity that we would do that in the actual production environment. What oftentimes gets overlooked, though, is testing the migration effort, making sure that when we have that limited cutover window, we're taking into account all of the different things that are going to strain that environment. So I didn't say this, I swear I didn't, but I don't always test my migrations, but when I do, it's in production. This was actually us collectively during the first RME cutover. We didn't test what the impact to that migration would be on the system. Now, again, not all data is created equally. The different sizes of those files, the different destinations, one going to a storage array network, a virtual storage array network, the other one going to provisioned IOPS, a third going to a database. We didn't really fully test what the impact of transferring 18 terabytes in a 72-hour window would do to that environment. We didn't understand the different failure modes. We assumed that if the data couldn't be written because we were running out of throughput or bandwidth, that it would just be a little slower. Well, that's not always the case when you're straining a system from an I/O perspective. So you may have heard the saying, animals under stress are unpredictable. Well, so are machines. These are two screenshots from the RME migration. The one in the background is perfmon. We're looking at the different CPU metrics. The one in the foreground is from the hypervisor. What this is ultimately telling us is during the migration, when we were writing all of these tiny little files, the system became unresponsive. The CPU pegged, and we all panicked. Now, we didn't consider that the migration effort itself was causing this at the time, because really the traits that we were seeing didn't line up with anything we'd seen before. We didn't know that when you sent these million files using UDP, because we were using a protocol at the time, a special tool to stream quickly, that it would overwhelm the I/O. That I/O would back up into the CPU. It would lock up Explorer. It would seize the whole machine up and ultimately make it unresponsive and unaccessible. So what did we do? What any system administrator would do when they think they have a faulty instance on their hands. We rebooted, and that didn't work. So then we destroyed it and rebuilt it, and that didn't work. And by that point, we'd wasted 1-2 hours trying to troubleshoot this issue that ultimately was because we didn't consider the file size. Yeah. Of the
and I think the
files.
conversation went something like this. I think it's me calling Mike and saying, hey, I think we broke AWS. I think that was the starting point of the conversation. But seriously, I think understanding all these nuances, and I think not just testing and doing the stuff in dev environment or queue environment. This is, I think, the beauty of the cloud is you can actually do a full production test, provision the environments. It's going to cost you a couple of dollars, but you don't have to go out and buy all new servers, have everything line up, provision exactly the same size, run it. You're going to understand the pinch points, and you can understand what you're dealing with. You have statistics to analyze the stuff and really understand what you're about to do before you actually go out and do it in prod. So key takeaway, test with the production-like environment.
So next is honoring the transfer window. The business has agreed to give you a specific point to make that transfer. It's important that, again, you include the failback mode, that you include any potential business constraints, maybe family constraints. For me, it was actually my wife's birthday during our transfer window. We were at a brewery at the time when the failure began to happen, and I had to rush away to go assist with the RME folks. So, it's important to consider all of the different things that are occurring during the transfer window that the business has allotted to you.
Yeah, and I think between April and June, I think I got extremely comfortable during the migration, and my executives were sending texts, "Are we done yet? Are we done yet?" And I told them, look, by 6 o'clock, we're going to be done. And by 5:49 or 5:50, we were done. I think having that confidence and building out that confidence to, no matter what's going to happen, you're going to land at the point in time, you need to build that confidence. If you're not confident about this thing, work on your iterations and get to the point where you know that if I'm going to take this data size and move it, by this time, I'm going to get it done. Another key thing to remember, it's not only the transfer window, it's all those nuances that could happen during that transfer window. Mike is going to talk a little bit more, but don't think you're going to be on the highway flying 90 miles an hour from here to whatever. Understand there's going to be traffic, and Mike, let me turn over to you because we're running into some of those scenarios, and let's talk about it.
Yeah, and that's a great segue. Respect the bandwidth of the interstate. When you can, precede the data. And the reason for preceding is it lets us shrink that transfer window. It also allows us to reduce the constraints of the network. So whether you don't have enough bandwidth or you have other applications that are mission critical that are competing for that bandwidth, you may not want to utilize it all in order to transfer your data all at once. So removing that network congestion as a potential blocker is extremely important. Now, there are a number of different ways to get your bits into AWS. We have the hardware-based methods, so think AWS Snowball for those petabytes of data that you may want to transfer, or Snowball Edge if you need compute during that transfer process. We also have tools for pure connectivity, so whether it's a VPN or Direct Connect, to allow you to gain connectivity with a consistent manner into your AWS environment. And then also application level. So for your servers, you can use Server Migration Service, which will actually replicate over time, allowing you to perfectly plan out that transfer window and cut over multiple servers all at once. Or if it's a database, we can do change data capture over a period of time to stream those changes and then simultaneously do the cutover. Now, one of the favorite unintended benefits of the migration effort, and all migration efforts, is the opportunity to document the architecture. For many legacy applications, the architecture is actually a composition of institutional knowledge, of runbooks that are there to help in the event of a failure or a DR scenario, or comments and scripts and code that can be piecemealed together to maybe eke out some comprehension of what's going on, but really isn't substantial enough to trust. For RME, we had this opportunity to take this information, form documentation from it, and then validate that hypothesis during the migration effort. That experience of the migration effort gave us the confidence that we had a clear understanding of our architecture. And with that understanding, with that confidence, we can walk into the refactoring process. We knew what every service did, we knew how it failed, we knew how to move it, and that allowed us to refactor the application, taking advantage of cloud-native technologies. So walking through that, on-premises environment had very little redundancy. It was a single application. There were some scripts there that helped reboot systems and restart services. The backup options were fairly limited because of the physical hardware and the throughput that was allotted to it. And that hardware was aging. It was coming up on its renewal plan. The initial migration to AWS was looking primarily to handle the availability and performance constraints of the on-premises environment. So we created 2 tightly coupled stacks. In the event of a failure, an engineer would still need to log in and fail over the systems. We changed the DNS endpoint, we'd start the services. This was step 1. But through that migration process, we felt confident that we had a complete understanding of the application. And that allowed us to begin that refactoring process. And the first thing we did was we used Lambda to run a health check on the 2 tightly coupled stacks. If the active node, the active stack, became unresponsive, Lambda would change our Route 50 our DNS entry so that it would use the other stack. And then it would also use, it would also run a script on the server to start the services required in the secondary stack. And this took our outage from what was previously 4 hours whenever there was an incident to 4 minutes as the Lambda function was able to start services, change DNS entries, and end users, the impact on end users and ultimately the business was far smaller.
Yeah, and look, I think before, just like any other companies, I want to give you a little bit color what Mike said around the time that it took. So usually you put in a ticket to the network engineers, they pick up this ticket, they have to do DNS, then they hand over this ticket to somebody else. So we actually looked as part of this as an opportunity to have end-to-end automation and really take out the humans out of doing the busy work. So by putting the right scripts in place, by putting the code as a serverless component who can observe the system, automatically react, and do whatever engineers would usually do, provided a tremendous value for us. So what we actually able to do, things will always fail. However, our business does not go down anymore. So we had a really high failure rate because we used old age hardware, and we had to deal with a lot of those nuances. Plus, when you take old hardware, you add people on top of it. Hopefully, everybody remembers to go from step X to step Y. By putting code in place, we were able to do a quick recover. And a lot of times when we have issues, the system does go down, but the scripts pick it up, replace it, and I think the beauty of the cloud. And from, I would say, more than a year, events did happen, but business was never aware that something was happening with the system.
Yep. And along with the improved availability, we also were able to gain lower cost. And we talked about that a little earlier, but that was through the implementation of S3. And a script was written to regularly copy older archive files off of those expensive EBS storage over to S3. And eventually, following business best practices, we placed it in Glacier for long-term storage. And speaking of data lifecycle, this is an area that comes up often. How do I put in place lifecycle policies and am confident with the results? The first thing is to leverage the storage class analysis. That's a feature that you can turn on your S3 bucket, run it for 30, 60, 90 days, and it'll track when objects in your S3 storage are actually being accessed or written, which will give you the opportunity to write those lifecycle policies in a more strategic manner. We actually just released a new S3 intelligent tier, which will take some of this off your plate for you. So I'd encourage you to look at that. It's also crucial to align the storage class to the business requirements. So you may have your compliance or legal team telling you exactly how long you're allowed to keep the objects. Make sure that your lifecycle policy aligns with that. That's something that we were able to implement with Army. And finally, don't fear retrieval costs. Organizations, especially enterprises, sometimes can get spooked by this idea that accessing the objects that they've stored in S3 or in Glacier will have a cost. That oftentimes isn't the case, especially for archived objects. We know that we may only need this object, in the event that there is an audit. That is not a reason to necessarily be concerned with the retrieval cost. So don't let the retrieval cost scare you away from using these lower cost storage options. Explore using something like the storage class analysis, exactly how often it's being accessed, and then go with confidence into that retrieval cost. Now, if we're talking about EBS and snapshots, over the summer we released the Lifecycle Manager for EC2. This will allow you to leverage tags to automatically snapshot your EBS volumes and then clean them up afterwards, so that you can use that for potentially backups with some QSing to the IOs on the volume. And those tags can also align with the tier that particular EC2 instance belongs to. So you may not snapshot as often for dev test as you would for production, things like that. So in summary, reducing the dataset size, both initially and for migration, is crucial. And understanding exactly what's needed from a data perspective to ensure that the application is ready for production on the cutover date. Understanding the data composition is also crucial. Knowing the size of the files, where those files are stored, the number of files, not just the size of the data. And finally, using this opportunity to learn, to validate, and to optimize your environment is something that we don't often get a chance to do, especially with legacy applications where they've been running for ages and we've crossed our fingers that they're going to stay online for the next few ages, or I'm not going to be here anymore when it is changed. Now we have that opportunity to go in, document everything, fully understand the system, pull that tribal knowledge out of all the brains of the consultants and folks that have been doing this for 10, 15 years, document it well, and then use that to actually begin the process of peeling apart that legacy application and automating the recovery and the optimization of it.
Yep. And I know Mike talked a lot about technical parts of this migration, but what I want to kind of summarize and bring it home, it's not really about the technology. So let me kind of walk you through a couple of things from the business perspective and how our business stakeholders looked at us. When we migrated this system to the cloud, the first business benefit is the system stays up and they can transact without any issues. The next thing, we were able to increase for the same cost, we were able to actually bring 3 times more users without adding additional hardware. We were able to reduce the overall cost to the business by 60%. We practiced a lot, so this thing developed a lot of internal muscle. And I think what I'm really proud of at the most, we took the second largest ERP in a Fortune 50 enterprise and we put it in the cloud. And what this done for our organization, it actually created a gravitational pull where if we have some voices to say, well, should we put this thing on the cloud, it stopped all those conversations. And also what it did for the team is really kind of, I know we talked about fail quick, fail fast, learn, move on. I think that really demonstrated how the team pulled together, how we quickly were able to learn from it, and actually internally start embracing the things that we always talked about and have actually a very specific example and success. And lastly, I think last year we decided to buy a company in Hawaii, and we're building the next set of this ERP platform because now we're in the cloud, we're able to start up, I have several people sitting here that stood up additional APIs, we were able to integrate additional business units, and we're talking about weeks, not months or sometimes years of implementing those big projects. So bringing the agility, using the platform, reducing cost, pulling as a kind of gravitational pull for the organization. And then even the COBOL-based systems now going through the DevOps, acting like a DevOps, and really talking about how do we deliver the business outcomes. It's really not about the technology. So with that, I know, thank you. I know you guys spend a lot of time, it's between us and a happy hour. We're gonna spend the next 10, 15 minutes. If anybody have any questions, we'd be more than happy to answer. If you want to ask a question, just come up to the mic.
Yeah, please come up to the mic.
So yeah, 2 quick questions. One, what did your mainframe platform look like at the start of your migration, and what was the total time frame from start to total migration?
So in the beginning, it was a traditional mainframe system running on ZOS. What we decided to do for cost reduction purposes, because we're challenging I think 6, 7 years ago, there was a challenge to continue keeping these EOSs. We migrated to Micro Focus platform. Part of that migration, we were able to take a lot of files and actually move them into database running SQL Server. And that was kind of the first cut of, let's just get from the ZOS. And we put on a traditional Windows environment. Once we start looking at the renewal, we looked at a lot of different options. And that was the second, what I would call the second iteration, where we're able to take the system and we're able to actually re-platform it to AWS. Now we're actually taking the bits and pieces of the functionality, what I would call a secret sauce. So I talked a lot about different modules. So for example, finance, we can go out and buy finance. But how we do purchasing, it's a secret sauce. So now we're taking that stuff, basically slicing that monolith into parts, creating APIs around that, and actually evolving the things that needs to live on. So that's the approach that we took.
You guys did this as a big bang switchover, right? Just all at once, one weekend?
Yes. So let me say yes and no, and let me walk you through. So what we're able to do is we were able to isolate the core data that resides in the platform, and we snowball majority of the data over to AWS. Then we focused and figured out what is that delta and start syncing the delta. So in parallel, we took the core data, then we figured out here's that delta, and over the set of couple of months, I think it's like months and a half, we actually every week can start bringing the data over to the new homeland.
So it was about 25 terabytes seeded initially, and then we initially had a 12 terabyte delta, and we brought that down to 8 terabytes for the second iteration.
So you initially just pointed your other application then, well, you couldn't have just pointed your old application to the new data.
No, so we were able to, we brought as much as we could, then we basically think about it, data capture without moving the system, continue, keep the basically two systems in sync. And then the big bang was to actually, okay, what's the remaining? We're gonna do a cutover, we're gonna move the remaining of the data, kick on, bring in new hardware, and change IP addresses. So our users were able to sign in. The only thing they were able to see is the same screens, and we added a little thing on the cloud.
So some of the stuff that I've heard in some of the other sessions is try to pick off some of the new things and just start creating some microservices so you slowly move everything over there. Did you guys consider doing that before you just moved your whole application at once?
No, and there's different reasons for it. Because if you start building the microservices, then you start really focusing where do you build them? Do you build them on-prem or do you move them to the cloud? And you're still dealing with the data sync issues. If you're building one or two data or microservices, then it's great, right? You can always sync the data. It's not a lot of complexity. But as you're building out more and more services, ultimately the syncing of the data becomes too complex. So for us, the step that we decided to do, and it was for different, I guess, business decision, we had to do the renewal on the hardware. So versus continue with the old model, we decided let's go back to the cloud and let's start building true microservices using true native cloud infrastructure, and that's probably the right thing for us. But again, this is not a wrong way or the right way. This is just the way that we decided that made sense for us.
Yeah, and to expand on that a little bit, for Army in particular, the primary reason that we chose the big bang approach was because of the data set size and the change rate of the data and the latency from its existing data center to the AWS location. The way that the folks interacted with it, the amount of time that it would take to rewrite into multiple microservices was a high bar, and so we decided to move first, get it as close as possible to those new services, those cloud native technologies, and then start that strangler approach of peeling away those different services. Yeah. There are other teams at Cisco for other ERP and management systems that are taking that exact approach. They're going the other direction. They've developed their microservices within AWS that communicate back to data centers on-prem. So not every legacy application or application in general is created equal, and it's really up to the business and the SLAs that you've put in place as far as response times to determine what the best approach is for that.
Yeah, I think this is just becomes your patterns, right? So you can develop and put together, here's 5 or 6 different patterns that exist in my ecosystem, and then you can apply the right pattern for the right business scenario. That's how I would, put in place. Any other questions?
You mentioned problems with the throughput of many small files.
Mm-hmm.
You were moving these into a Windows server, NTFS file system?
It was actually an EBS volume attached directly to a Windows server.
Okay.
Yes, and NTFS file system,
Yeah.
correct.
I've seen similar problems in a different context of really large file servers performing very, very badly under VMware with NTFS, and we did some benchmarking, and on the same hardware natively, we got 40 times better performance. And then we tried virtualization with ZFS, so not NTFS, and it was only a penalty of about 5%. So our experience has been that NTFS is disastrously bad when you have many small files. Did you consider moving files first onto some sort of staging system that is not an NTFS volume?
We did. The issue was, going back to, if you're recalling those slides, we didn't test the migration effort initially. So by the time we were prepared to make that sort of assessment, we'd run out of time. We were trying to think of other ways that we could go about it, but ultimately what we landed on was it would have to end up on NTFS because that was the file system that was used by the application, the service that was running on the server. So at some point in time, we'd still need to make that final leap. I mean, we'd walk through, okay, normally you do something like archive them. You zip up a bunch of files together so you get that perfect block size in order to write that and take full advantage of the I/O. But at some point, we would have to
Unpack it. Yeah.
unpack that, and then we'd run into the same constraint. So this really boiled down to not being able to take full advantage of the I/O for our particular instance type, but that's great information as far as using a different file system if you have that sort of capability.
It helps a lot, yeah.
Yeah.
Okay, thanks.
Thanks for sharing.
Yeah, and just for the clarity, this is just only during the transfer window. It's not, natively, the performance is going to be up to par, but he's absolutely right. There's different options available, and then it really comes down to test, so you know exactly what you're dealing with. And for us, look, we tested, we knew the window, it worked for us, and we were able to successfully get it done.
So when you migrate your data first, what kind of schema changes did you guys make on your new schema so that your microservices could perform better than the schema that you had on the mainframe?
So we're actually able, I can talk to that. So if you go to the second options by moving over to the cloud and then setting up the microservices, ideally what you want to do in the true microservice pattern, you want to take the data that a microservice relying and put on a completely different database. So now because you're in the cloud, you can take that data, you can do DynamoDB, you can put on another SQL Server database, you can use whatever database you want. So you can isolate the data that's relying on, for that microservice, move it over, and then transact against that data. So that's the technique that we use successfully. Or, based on your volume, you can actually create a small microservice with the JDBC or DBC connection back to the original database table. And if you're not getting hit with a lot of volume, and you can use that technique as well, where you can write back to the table of origin.
So you could have your microservice in doing the data that you'd want just in the old schema.
Yeah, and usually it's an anti-pattern if you're saying it's a true microservice. But the idea is, look, you can take whatever data you need in order for you to transact, move it over, create a new microservice on top of it, and then sync up the changes if needs.
Thanks.
That's the approach that we use. Just come up to the microphone, please.
Over here. We haven't had anybody over here yet.
Sorry.
So
You can go
One sec,
next.
Yeah.
Go ahead.
Is there any additional effort to choosing the migration solution or the monitoring tools during the migrations? Because the system is separated because you have to monitor the both of system in the on-premise and AWS Cloud during the migration. So before the migration, you must be the POC or some solutions and monitoring tools.
Yeah, so we've done, the way that we started, actually, Mike sitting here in the front, we actually said, look, we want to do this stuff, We never done this scale before, and we actually spin off a true, proof of concept, proof of value, whatever you want to call it, and we actually went through those steps to say, can we even do this stuff? And we were actually able to run through the scenarios. This is where some of the conversations we had during this talk, where you can take a system, instead of going out and buying a brand new hardware, you can say, give me a production-like volume for the next 2 weeks or months, run it, go through the exercise and make sure that it's a valuable solution. And this is where we created a really key, what I would call exit and entrance criteria to say, in order for this to be successful, here's the sequence of things that needs to be true. So for example, we wanted to make sure that a batch job runs, 3 critical batch jobs run a lot faster than the on-prem. We validated that that worked. We wanted to make sure that the data sync between another system and our ERP system works. So we went through that exercise to make sure that we're actually benchmarking transactions that real time going from one system to another. So I think it's scripting that like key critical components. Obviously you're not going to be able to do a full migration, but I would strongly recommend do a true POC, but make sure that you have clearly defined entrance and exit criteria where you can say, here's when we start the project, here's how we're going to end the project, and here's what success looks like on paper. Go ahead.
Can you talk a little bit about security and compliance regarding this project as well, and what, not necessarily roadblocks, but what issues and concerns that those teams came up with that you had to get around?
Sure, I can talk and Mike, feel free to add. So one of the things that we wanted to make sure we got legal involved as well as corporate finance and corporate audit to walk them through all the different scenarios that we wanting to do. From the security perspective, just getting business to kind of bring them up to speed and make sure that they fully understand that AWS security is going to be a lot better than we can do in-house. There's a couple of things that we have a direct connection to AWS as well. So we have a secure connection. We're not sitting on the public cloud where we have all the systems exposed. So making sure the security part of that initial POC, that they actually working side by side. And it's not just about the security, it's bringing your legal, finance, audit on board and actually walk them through, here's what we're trying to do, here's how it's actually going to help you support your business policies. I think that's important things to bring people along for the journey. And then what I would say, this is not just a technical, I'm going to play, project that I'm just going to play with the hardware. It's making sure that everybody understands the why part. You want to add anything to it?
The one thing that I'll add is because we chose a big, hairy, complex, mission-critical, every compliance checkmark and security checkmark that the organization needed to be able to pass for this effort, it cleared the path for efforts down the road and made it a much cleaner journey for other applications, whether native or migrations that came after it. So Cisco's been able to really accelerate their cloud adoption in a streamlined manner because the language is now the same for security. They understand the nomenclature of the cloud. They understand the new controls that are in place and what they replaced from the existing environment. So it was just a matter of ensuring that the communication and the terminology was understood and that those new controls were well understood.
Yeah. It's creating that gravitational pull that I was talking about, but tactically we'll actually set up a really good framework for archiving that's been validated by legal. And what we actually do every time that we start a cloud migration, our other business teams or DevOps teams actually adopting that same framework. It's been vetted by legal, it's been validated by all the right teams, and this is just, okay, I need to do X, Y, and Z. Here's the framework, guardrails where you can, so it actually makes it a little bit easier. Any other questions?
Did you have a question?
You mentioned previously that you were running on Z architecture, ZOS. So did you face any challenges converting it to Intel-based or moving to AWS? Like, did you need to make extensive changes to your application before you move the data? And what challenges did you face?
Yeah, so remember this is a two-step approach. So when we came out from Z, we already converted the data, and we took some of the critical tables from flat files into database. So now that was the first step. And then the second step, what we've done, actually take that stack and moving to the cloud. And actually, with some of the things we were able to optimize, and again, goes back to the thing that I was just talking about, it's making sure that you have the right statistics, the right numbers, that you guys can actually go back and look, is it better or worse? We, when we ran the initial test, we actually found out that the nightly job ran a lot worse. So we're like, ooh, that's not good. And we went back and we started playing around with a couple of different options, and ultimately we got 3 times better performance. But again, measure, measure, measure. I think that's a key takeaway. It's not a magic bullet. So with that, thank you. I really appreciate you guys staying out till almost 6 o'clock.
Please complete your surveys. Enjoy the pub crawl. Thank you all.
Thank you, guys.